Today we're going to use triple integrals to find the volume of the given solid, the tetrahedron, enclosed by the coordinate planes and the plane 8x plus y plus z equals 2. The first step is to find each point. Using the equation of the plane, he set y and z equal to 0 and found x. You would do this 2 more times to find y and to find z. Now that we have the points, we can graph them. Hong will draw our ZYX axis, axes. There's our 1/4, there's our 2, and now he's going to draw the tetrahedron. Nice. Now the next step is to draw the points in the XY plane. The reason for this step is to find the X and Y limits, or bounds. We can see first that X is going from 0 to 2, 0 to 1/4. For Y, we need to find the equation of the line. This is taking it way back. So you do y2 minus y1 over x2 minus x1, and that will give you your m. The equation is y equals mx plus b. B is the point of intersection on the y-axis, which is 2, and the m was -8. Since we have the equation of the line, we can now find our bounds. The bounds go from 0 to 2 minus 8x. The last point we need to find is the z. Now Hong is rewriting the equation of the plane given, and he's solving for z. Since z equals 2 minus 8x minus y, that will be our upper bound. And you could verify that by going back to our 3D graph, and we see that z goes from 0 to the top of the plane, which is 2 minus 8x minus y. Now that we have our 3 bounds, we can jump into the triple integral. We're trying to find volume of the solid.
George, have you started working with the take on?
So the equation we're going to use is 1 dV.
Started working on the graph.
Which one are you working on? Oh.
On the graph of this one.
Now these 3 bounds match these bounds. If you look closely, you can see we're going dz, dy, dx. 0 to 2 minus 8x minus y, 0 to 2 minus 8x, 0 to 1/4. The first integral we'll be doing is the inside, which is the dz. This works out nicely, nice and easy.
Do you
Now we could jump into the dy integral. As you see, the 2 gains a y, the 8x gains a y, and the y becomes 1/2 y squared. For each y, we will plug in our boundaries. The 0 works out nicely, and now we can jump into the dx. In that step, he just rewrote it to an easier equation. No, the 32x squared will turn to 32 over 3x cubed minus 8x squared plus 2x. Now we will plug in our bounds. At 1/4 we'll place the x. If you plug it in the calculator, it'll come out to 1/6. And that is your volume of the solid. For a quick recap, the first thing we did was find our points by using a 3D graph. Then we transitioned to the XY graph and found the XY points. We found Z by rewriting the plane given. We know it goes from 0 to the top. Then we use the volume formula, which is just 1 dV. We plug in our bounds from here. And then we started integrating. We did the dz first, then we did the dy, and then the dx. And that gave us our answer, 1/6. Thanks, Hong.